they want in part A? Tell me. Yeah, read carefully. They don't want the definition. They only want the formula. What is the formula? C equals QV, isn't it? No, sorry, I have that. Yeah, I usually write it as Q equals CV. So that means C equals Q over V. That's it. Okay, 1 mark. Now this one looks a little bit tricky. 2 capacitors, capacitance of 20 microfarads and 12 microfarads. They're connected to a 30-volt battery and then disconnected. So what happens here is the first one is charged up, then the second one is charged up. So for 1 mark and 1 mark, what is the charge on each? Well, that's super easy. So B part 1, what's the formula? Q equals CV. So that will be, 20 times 10 to the 6 times 30. Yep. So that would be 600 well actually maybe it would be, let me type it in. 20 times 30 times 10 power minus 6. Yeah, that is 60 milli. 60 millicoulombs. Or just, you don't have to write it using milli, I just like to when I can.
Is that minus 6?
Yeah, sorry, I lost it again. Minus 6. That's for A. Then for B, same deal, except it is 12. This one here is, hang on, did I type something in wrong? They're both the same? That's not right. Let me try it again. 12 times 10 power minus 6 times 30. Yes, sorry, now I got it. That is 0.36. Yeah, well, 0. That is much smaller. Hold on. 12 times 10 power minus 12 times 10 power minus 6 times 30 divided by 10 power minus 3. Yeah, that's much, much smaller. I wonder, did I do the first one wrong? Is that right there? 0.6. Oh, I left out my point, was it? Thank you. 0.6 milli. And 0.36 milli. Okay. Charge on A, charge on B. Next part is if you put them together, what's the total charge? Now they're in parallel though, okay? So when I put them together in parallel, how do I add their capacitance? Do I use 1 over or not? No. So it's just going to be 20 microfarads plus 12 microfarads total, 32 microfarads. I'm finished. What is the total capacity? It's there. Now, I am going to do something they didn't ask me to do, but I have a feeling maybe I need it later, or I would just like to know. So I just would like to know what is the charge in this system. The charge in this system would end up being .96 millicoulombs. Yeah? That's kind of nice, isn't it? Because if you look here, it is what you might expect. That was the charge in the first one. That is the charge in the second one. When you combine them in parallel, that is the charge for the combination, which here is actually plus. And the reason it works out nicely like this as plus is because you use the plus formula here when you combine the A and the B together. This doesn't work out as nice when they are in series. Okay. Part C now. So actually the answer was actually just this is what they wanted. Okay. Part C. The two charge capacitors are then connected in parallel so that the negative terminal of A is connected to the positive terminal of B, as shown by dotted lines in the diagram. Electrons flow in the direction shown on the diagram until the voltages of the two capacitors are equal. Find the value of this final voltage. Okay. I think something interesting happens here, and I'm going to check the answer, okay? So, can I scroll down? Yes?
Yes.
I don't want you to write this down just yet till I make sure it's right, okay? But if you look at the diagram, they say, if you can see on the diagram, think about the battery. Well, no, it's actually not the same as the battery. But if you see on the diagram, they say the electrons are moving this way. So what you need to picture is there's lots of electrons charged here, and then they're coming out that way. Okay? But if you look at the other plate, it's backwards, isn't it? The electrons are actually on the other side. Yeah? So, really what I mean by this is all negative. This is all negative charge, meaning here is positive charge, and here is positive charge. So what happens when these electrons hit this plate? They cancel, don't they? The negative charge hits the positive charge and they cancel. How much charge was in this top one? What was my answer for that? How much was it? 0.6, was it? Yeah, it was 0.6 millicoulombs. And how much was here? 0.36 millicoulombs. I think this second capacitor is going to cancel some of this charge. That means what will happen is this. When all the charge here has left, it will pass through this one. There'll be some that cancels, and basically what you're left with is just the charge of 0.42, is that 44? That's 24. 0.24 millicoulombs. That's how much is left. Then what will happen is that charge that's left will recharge the two capacitors here. So you'll end up with charge here and then charge here. Okay, so if you think about it a bit like this, imagine I have like 2 cups of water, something like this, okay? And then I let them discharge. The only difference in my example is with the 2 cups of water, this cup of water, the water actually cancels in the other cup, okay? So when I combine them, this water cancels this water, leaving me with less. And then what happens is, because it's a loop, the charge then just goes back into the 2 cups then. But in other words, there's less than what you started with. So we know the charge at the end, and we know the capacitance of the combination, and we want the voltage. So which formula do we use? Q equals CV. So if I have Q equals CV, that means V equals Q over C, which is 0.24 times 10 to the minus 3 over, what was the capacitance combined? What was it? 32 micro, was it? What was it? Come on. 32 microfarads. Alright, let's see what we get. I got 7.5 volts. Now, like I said, let's just check if this is right, because I don't feel confident. NCUK, you're confident?
I checked it.
Oh, you already checked it? Oh, great. I'm happy. Alright, so you can write